MAT121. We're going to go back into functions. We're going to talk about a composite function. A composite function, you have done this before, just never given the official title. If you were doing orders of operation, you sometimes ran into a case where you had inner parentheses, outer parentheses or brackets, and you were always told you had to simplify the inner one first, then work yourself out to the outer grouping symbol. That's exactly what's happening here. A composite function is denoted by F with not an O, it's just a circle, if you will. G, which reads F composed with G, or F of G, is defined by F composed with G of X, or I prefer this notation, F of G of X. The first function letter given is always the outer function. The last letter is always the inner function name. Now, it's important to understand that the domain of F of G, or F composed with G, is the set of all numbers x in the domain of the inner function G, such that G of X, which is your y coordinates, is the domain of F. And that's what makes it seem weird, because you're saying y coordinates are going to be the domain. Well, the y coordinates of the G are the range of the G function, but in terms of the F function, they're the domain. So a flow chart looks like this. I start with my x, put it into my inner function, I simplify it, and the output is the y coordinate of the G function. But then that value is going to become the input, or the x value, going into the F function, which gives us the output of the y coordinate of the F function, excuse me. So if we look at a numerical example, here we have h of x is 2x squared minus 3, j of x is 4x. Find h of j of 1. So this is better written as h parentheses j parentheses of 1. So 1 goes into the inner function j first. That's 4 times 1. But it stays in the parentheses of the h function. So 4 times 1 is 4. And now 4 goes into the h function. So now we take this 4, which again was the y coordinate of the j function. Now that 4 becomes the x coordinate of the h function. 4 squared is 16, times 2 is 32, minus 3 is 29. So h of j of 1 is equal to 29. And it's important to realize that if you switch the numbers, or excuse me, the letters around, but keep the same number, you do not always get the same answer. So j of h of 1 goes into the h function first. So we'll square the 1, that's a 1, times the 2, that's a 2, minus the 3 is a negative 1. So the y coordinate of the h function is negative 1 when x was a positive 1. Then we take that negative 1, we put it into the j function, we get 4 times negative 1 is negative 4. So j of h of 1 is equal to negative 4. As you can see, we don't get the same values. We can also have a function of itself, h of negative 2. Negative 2 goes into the h function for that x. Negative 2 squared is 4, times 2 is 8, minus 3 is 5. Now that 5 has to go back into the h function one more time. So 2 times 5 squared, 25 times 2 is 50, minus the 3 is 47. So h of negative 2 is 47. J of negative 1, it's going to look like this. Negative 1 goes into the j function. 4 times negative 1 is negative 4. Then take negative 4, put it back in the j function. 4 times negative 4, negative 16. So j of negative 1 is negative 16. Now, what happens when they don't give us numbers? Don't panic. We saw this before. If they give you a numerical value, you come back with a numerical value. If they give you a variable expression, you come back with a variable expression. using the same value. So h of j of x, written like this, means go find the j of x function, 4x, and substitute it into the h function. So this 4x is going to go into that x of the h function. So 4x, all that squared is 16x squared, times 2 is 32x squared minus 3. That's as far as I can simplify it, therefore I am done. H of j of x is 32x squared minus 3. J of h of x, now we're going to take the h function, that's the inner function, 2x squared minus 3, put that in for the x of the j function. So 4 times the 2x squared minus 3, we'll do a distributive property. 4 times 2x squared is 8x squared. 4 times minus 3 is minus 12. You are now done. There's nothing to combine. So we are done. Another problem that you'll look at is they'll say find the individual functions f and g such that f of g is equal to capital H, and they give you capital H, and it's let's say it's equal to the square root of x cubed plus 5. So by notation, f of g of x is equal to capital H. So looking at this, the first thing I ask myself is, who's the inner function? Oh, that would be the g of x. G of x is inside the parentheses of the f function. Then I say, okay, let's go to capital H. Who is inside of a grouping symbol here? Well, that'd be x cubed plus 5. Okay, so g of x is equal to x cubed plus 5. I go up to where capital H is. I take out the x cubed plus 5, replace it with an x, and that's my f of x function. So if I take g of x, x cubed plus 5, and I substitute it into that x, I get capital H. Another way that you can find f and g is to go after the variables with powers. So I look at capital H again, and I say, okay, where's my x with the exponent? There it is. That's my inner function, g of x. Take that out, put an x back in. That's my f of x, the square root of x plus 5. So again, if you take the g function and you put it into the x of the f function, I get the square root of x cubed plus 5, which is capital H. Now you only have to find one set. You don't have to find both. Down below, same concept. Now my capital H is x squared plus 1 all to the 5th power. G of x, again, is my inner function. So who is ever inside my grouping symbol parentheses, x squared plus 1, that's my g function. Take out all of x squared plus 1, replace it with an x. You get x in the parentheses to the 5th power, which simplifies to x to the 5th. Again, second method, find the x to the power, that's your g function. Take it out, put an x back in, x plus 1 to the 5th power, that's your f of x function. You can use either technique which best suits you. Now our composite function is going to lead us to what we call one-to-one functions and inverse functions. A function is one-to-one if any two different inputs in the domain, that means two different x coordinates, correspond to two different outputs, y coordinates, in the range. That means your x's can't repeat and your y's can't repeat. So if we wrote this out in function notation, f of x sub 1 cannot equal f of x sub 2. If this happens, you have what is known as a one-to-one function. All right, now, when we look at one-to-one functions as a graph, we remember there is the vertical line test. Okay, here's x squared, it's a parabola. It passes the vertical line test. Here's x cubed, passes the vertical line test. These are both functions. But in order to be a one-to-one function, now they also have to pass a horizontal line test. So if I put horizontal lines on my graphs, okay, here we got a problem. Now the blue lines touch the graph in two locations. This is not one-to-one. It's still a function, just not a one-to-one function. Over an x cubed, all the blue lines touch only once, therefore that's a one-to-one function. So remember our rule of what's supposed to take place here. In order to be a one-to-one function, the x has to go into, it's a composite function. X coordinate goes in for the y. So let's say x is 2, you get a 4, x squared. I take negative 2, put it in for x. That's positive 4. 2 squared 4, negative 2 being squared is 4. So my problem is if I start at 4, how do I know where to get back to? That's the key. And that's the concept of inverse functions. This little negative 1 that looks like it's in the exponent position, it's not an exponent. You read this as the inverse of f of x. F with that negative 1, that's inverse of f of x. This definition says it's a relation such that every x coordinate in the domain corresponds to exactly one y coordinate. Okay, stop. That's the definition of a function. A relation such that every x coordinate in the domain corresponds to exactly one y coordinate in the range. And every y coordinate in the range corresponds to exactly one x coordinate in the domain. Remember with our original function we said x's can't repeat, but the y's could. Now if I switch x coordinate, y coordinate, x coordinate, now nobody gets to repeat. X's can't repeat, y's can't repeat. So to be an inverse function, the number one thing I want you to remember is switch all x and y concepts. I don't care if we're talking points, we're talking on a graph, we're talking variable expressions and equations. We're going to switch x and y's. So the domain of f, this is the x's, they will be the y's of the inverse function. The range of f, that's the y's of the original function, is the domain of the inverse function. Those are your x's. So flow chart looks like this. If I have a function, my x goes into the f of x function and out comes a y. Now, you take the y coordinate, you put it into the inverse function, I have to come back to where I started x. This concept gives us the inverse identity. The inverse of f of x has to equal x. F of the inverse of x has to equal x. So this one here, f of the inverse of x, that was this path that I have with the arrows. I come back to x. If I do this, this one here, f function first to the y, then the y through the inverse, that's this one. If I look here on the right, starting with the inverse function, starting with y, or again your x, I would go here to here, then into the f function, I'm right back to where I started. So that's the key. Now, if you were asked to verify functions are inverses, suppose you have 2x plus 3 and g of x equals 1/2 times x minus 3. Well, let's color code this. Let the f function be in blue, g function in red, and you have to show one of those two identities. It doesn't have to be both. You pick the one you want to work with. So if I opted to do f of g of x, g is the inner function, f is the outer function. You take all of g, put it into the blue x, that's what I have right here, and now you start simplifying. 2 times the half times the binomial. The 2 gets multiplied to the half, that cancels each other out. X minus 3 plus 3, minus 3 plus 3, they cancel out. F of g of x is equal to x. That's good enough for me. They are inverse functions. Or if you decide to go g of f of x, and again, you only have to do one. 1/2 is the g function. X minus 3, you take the blue 2x plus 3, put it in for the red x. Okay, start to simplify. Nothing's being multiplied to the blue parentheses, so therefore plus 3, minus 3, cancel out. 1/2 times 2 cancels out. I'm back to x. Let's verify if these are inverse functions. F of x is 2 times the cube root of x minus 5. G of x is, in parentheses, x over 2 cubed plus 5. You pick which one you want to do. All right, so pause the video. Either do f of g of x or g of f of x and see if you can get it to equal x. If you do, they're inverses. So pause it, and when you got your answer, turn it back on. All right, welcome back. Here we go. We're going to take f of g of x. We're going to take all of this, put it in for that x inside the square root. There it is. Really don't need those parentheses because nothing's being multiplied to it. So plus 5 minus 5, they cancel. Then we have 2 times the cube root of something cubed. Those cancel. It's 2 times x over 2. The 2's cancel. I'm left with x. If you tried g of f of x, then we take all of the f of x, put it in the numerator of this fraction here. Well, since I'm in this fraction, 2 and a 2 on the top and the bottom, they cancel. Then I'm left with the cube root of x minus 5 cubed. That cancels. Then I'm left with x minus 5 plus 5. Those cancel out, leaving me the x. They're inverse functions. If you're given a function that is a set of points, switch all your x and y concepts if they ask you to find the inverse. The inverse of f of x means the x coordinate becomes the y coordinate becomes the x coordinate. So this first point, negative 27 comma negative 3. Negative 2 comma negative 8 becomes negative 8 comma negative 2. Negative 1, negative 1. I switched them. Did you see that? Still negative 1, negative 1. 0, 0. Switched them. 1, 1. Switched them. 2, 8. Switch them. 8, 2. 3, 27. 27, 3. Close off the set with the brace. There is the inverse function. We can do the same thing with a graph. Find your starting points, find any turning points, write them down. 1, 2, 3, 4 to the left, negative 4, negative 3, negative 2, 0, and 4, 2. Write them in order as you read it from left to right. Then just like we did with these points, switch them. Negative 4, negative 3 is now negative 3, negative 4. Negative 2, 0, 0, negative 2, 4, 2, now 2, 4. Plot the points in order, negative 3, negative 4. 0, negative 2, and then finally 2, 4. Now, you saw that line appear and disappear. This is the line y equals x. Some authors refer to it as the inverse line. You definitely can see it right here. Negative 1, 0, 0, 1, 1. All those points are on that green line. If you take your blue function and you flip it over that green line, y equals x, you get the inverse graph. If I have a function that's an equation, f of x equals 3x plus 5, again, I have to switch x and y concepts. So f of x, I take it out. I rewrite it with a y. That's worth a point. Rewrite it with the y to get a point. Step 2, switch x and y. Switched, that's worth a point. Step 3, solve for y. Get y by itself. Everything that you undo, worth a point. Subtract over the 5, that's a point. Divide over the 3, that's a point. 1, 2, 3, 4, and the last step, take out the y, replace it with your inverse notation, that's a point. Now, folks, be very careful. Remember, it's got to match the letter here. You notice there's a lot of f of x's going on here. Don't get brainwashed into everything is f of x. Next example, oh, here we go. G of x is 3/4 x minus 1. Okay, follow the steps. Take out the g of x, put in a y. That's a point. Physically switch the x and y around. X equals 3/4 y minus 1. Solve it for y. Add over the 1. To get rid of the multiplication of 3/4, multiply by its reciprocal 4/3. Put parentheses around the left side. 4/3 times the binomial x plus 1. You do not have to distribute it. Just leave it. You got y by itself. Now put in the inverse notation for the g function. The inverse of g of x is 4/3 times the parentheses x plus 1. All right, let's do h of x. It's the cube root of x plus 6 minus 4. Follow your steps. Take out the h of x, put in a y. Physically switch x and y. Two of the easiest points you'll ever earn. Now we need to get the cube root by itself to solve for y, so we add over the 4. Get rid of the cube root symbol by cubing it. Now I have y plus 6. Get y by itself, subtract the 6. Leave it on the outside. Did you notice there's no arithmetic being done whatsoever? There's my y. Replace it now with h inverse of x. There's my inverse function. Now, delicate matter. Let me pause this for a second. Go back to this graph right here. Remember how we said x squared was not 1-to-1? It has to be 1-to-1. We're going to figure out a way to get it to pass the horizontal line test. That's our goal. All right, so here we go. Find the inverse of f of x, which is the square root of x plus 5. I put in the y for f of x. Steps are good. Switch the x and y. Good. Add over the 3. Even better. Square both sides. X plus 3 squared. Square root gone. Y plus 5. Subtract over the 5. Good. Put in my inverse notation. Good. I do all that. And then all of a sudden it says minus 2. I lost 2 points. Here's the problem. You wrote down a parabola, which we have not proven it to be a 1-to-1 function yet. So I went to my calculator. I typed in y1, the square root of x plus 5 minus 3. I typed in my inverse function, and I typed in y equals x. Here's what my graph gave me. So I blew this up so you can see it. Here, that is the square root of x plus 5 minus 3. Here's my y equals x line. Now remember we said a true inverse graph flips over that line. This point lands right at the vertex of my parabola. But my y equals the binomial x plus 3 squared minus 5 gives me the whole binomial. I just want half of it. So what I got to do is find my vertex. Oh yeah, that's right. This is in vertex form. My vertex is at -3, -5. So at this x coordinate, I want my x's to be -3 or bigger. Once you attach this domain restriction, you don't lose the 2 points. Now I forced that red graph on your screen is the binomial x plus 3 squared minus 5 with a domain restriction of bracket -3 comma infinity, or x is greater than or equal to -3. That means this part of the graph here is gone. And now it passes the vertical and horizontal line test. So now this is 1-to-1. You have to add the domain restriction. It's a must. So here's the rule. If you're given y equals a positive square root, you want the right side of the parabola. Your domain will be h comma infinity. I like using inequalities because it says x greater than or equal to h, which is the x coordinate of your vertex. I want to go to the right of that x coordinate, right side of the parabola. If y equals a negative square root, you want the left side of the parabola, which is the domain -infinity comma h bracket. But what I have found when people do interval notation, they sometimes get the h and the -infinity switched around. So safest thing to do, write it as an inequality. I want the x's that are to the left of the x-coordinate of my vertex. Then I get the left side. All right, memorize that rule. Find the inverse of f of x equals negative 2 times x plus 1 squared minus 7. Wait a minute, that's a parabola. It's not 1 to 1. Oh, yes, it is. I attached a domain restriction. X plus 1, h is negative 1. That's where this comes from. So then this is perfectly legal to find the inverse. Now, because I want the right side of the parabola, it's going to the right, then I'm going to be looking for a positive square root symbol somewhere in my work. So I put in my y for f of x. I switch my x and y, again, the two easiest points you'll ever get. Add over the 7, divide by negative 2, just leave it as a fraction, don't do any work with it. Get rid of the power of 2 by the square root. Aha, here comes your plus or minus. We want it to be positive, so leave this positive, subtract over the 1. There is my inverse function. So again, 1 point, 1 point, 1, 2, 3, 4. Rewrite it with your inverse notation 5. Well, that's about 7 points right there. All right, and that wraps up 12.1.